Hi guys! In this video we are going to talk about smooth particle hydrodynamics, or short SPH. I had noticed that a few people on Twitter seem to be confused on what this algorithm is actually doing, so I want to cover this a little bit. Smooth particle hydrodynamics was developed for astrophysical problem solving initially, but is now often used to simulate how fluid behaves. When researching, I even found a paper where they use SPH to calculate something for fuel injection into an engine, which is quite amazing to me. SPH is what we call a mesh-free Lagrangian method where the coordinates move with the fluid itself. To describe it in layman's terms, an SPH is simulating a fluid by utilizing particles which you could view as water molecules or water drops for easier understanding. It calculates the acceleration of each of the particles with the position and speed of its neighboring particles. Now this value is going to be impacted by things like pressure and friction. For example, if particles are really close to each other, then the pressure acting between them is higher, or if the neighboring particles happen to have a different speed, there would be an impact on the friction. But let's stop rambling and jump into the code. We begin by creating a class for our particles. In there, we are keeping track of values like the game object, position, velocity, and so on for each particle. For our particle colliders, we are using quads, and of course a class to describe them in code. With these two classes done, we can now jump straight into the simulation code, which I have in my manager class. At first, of course, we need to set a few variables, which are partly our particle settings, but also some constants that we are going to use to calculate the behavior. And of course, there are arrays to help us keep track of our particles and particle colliders. I am initializing my version by spawning my particles as a rectangle. How many particles there are per side is depending on my per row value. I am also adding a little bit of variance in my calculations for my x, y, and z to prevent the spheres from just falling straight from heaven. They should look natural, which can be easily achieved by adding the tiniest bit of randomness. The first things we need to calculate for our particles are their density and pressure. We are doing this by looping over our particles twice to get the current particle and all others in comparison. To calculate the density, we need our current particle and its distance to the next one in the array. If their distance is smaller than the set smoothing radius, we calculate the new density using the particle mass, smoothing radius, and distance. For the pressure, we are simply multiplying our gas constant with the current particle density subtracted by the rest density. Let's jump to the particle movement. Here we are again doing our nested loops. To calculate the force pressure as well as the viscosity, we are again using our smoothing radius to make sure that the particle is close enough to our current one to be included into our calculations. Once we've calculated force pressure and viscosity by using our close-by particles, we can calculate the impact of gravity. These three forces will be combined and help us to calculate the velocity for our particle, which we now only need to use to calculate the current position utilizing our delta time multiplier. Our last step would be to introduce collisions. Like I said before, I'm using quads here as my colliders. We are again using a nested loop, but this time we are looping through our particles and all of our particle colliders. In our collisions function, we are basically just checking if our current particle is intersecting with our collider. If it is, we are dampening the velocity to simulate a collision and adjust the particle's position accordingly. I of course added a bit of a UI that allows you to play around with values, but this is everything. I hope you try this out for yourself. As always, the source code, this time including the ECS version of this, will be available for Coder tier patrons. Links to it, as well as to all my other social media, will be in the description box down below.